I welcome all to the course on Control System Engineering. In this video, we will learn the open loop and closed loop control systems with examples. Before going to discuss about open loop and closed loop control systems, let us know what is meant by a system and what is meant by control system, and also what is the need of control system. Then we'll see first what is a system. Generally, the system is a collection of elements or components contained in a sequence to perform a specific task. If the output quantity of the system can be controlled by varying the input quantity, then the system is said to be control system. Then why this control action is required for the system? Now we'll discuss different areas where the control is required, control action is required. For power amplification, in some systems like radar antenna, to maintain its position, we need to give the amplified power to produce high torque on the radar to achieve the desired position. In remote controls, to control the movements of the robot, to work in a contaminant areas where the human being is not aware, is not allowed, we need to control the movements of the robot. Then for convenience of the input form, to in the temperature control system, to maintain the desired temperature of the room, we need to control the knob position. For compensation purpose, when the disturbance occurs in the system, we need to compensate the disturbance to achieve the desired output quantity. For example, in the antenna position, when it is disturbed with a high or a strong wind, then we need to compensate this disturbance by varying the input quantity or some parameters to maintain the desired antenna position. Now let us see the open loop control system model. This is the open loop control system model. Basically, the open loop control system consists of a controller and process plant, where the reference input is given to the controller. Based on the reference input, it gives the control signal to the process, then the process will deliver a controlled output. But here the controller doesn't bother about what the output is delivered by the process. That means irrespective of the output, whether it is our desired output or not, the control system will deliver a continuously is the same output. This is called the open loop control system. Now we'll see some examples of open loop control system. See, what is this example? It's a hand dryer, electric hand dryer. When you keep your hand under the hand dryer machine, then internally the air will be heated and blown out continuously, and hot air comes out to the hand and hands will be dried. As long as your hand is under the machine, whether your hand is dried or not, the hot air will come out from the dryer machine. That means the system doesn't bother about whether your hand is dried or not. This is an example of open loop control system. And the second example is automatic washing machine, where the clothes will be washed based on your time set in the washing machine. When the power is on and the time is set, the motor runs and spins the clothes inside. Then what washed clothes will be come out. As long as the timer is running, the wash will be spinned out, and after the time is 0, then the clothes will be come out. Here the washing machine doesn't bother about whether the clothes are washed or not. It depends on the timing value. If we set the time, then until that time becomes 0, the clothes will be spinned, and after 0 it will be come out. This is another example of open loop control system. Now see, this is the example of another example of open loop control system. Can you guess what is this example? Yes, this is a traffic light control system where we'll set the time, the timer, the in the controller will set the time until what time the lights will be on. When the power is on based on the time set, the lights will be on, and it doesn't bother about whether the traffic is there or not. This is called the open loop control system. Now we'll see what are the advantages and disadvantages of open loop control system. These are the advantages of open loop control system. The construction of the open loop system is very simple because there is no feedback, there is no continuous monitoring of output variable. So it is having simple a transducer, controller, and a plant so that we will get a desired a controlled output. It may be a desired output or not. Don't bother. Simply the construction is very simple in open loop control system. Due to less number of components and there is no control action on the output variable, it is economical and also very easy to maintain. This is all due to the feedback absence. So no need to continuously monitor the output variable. Therefore, the maintenance also is very easy. Once the input is given, the controller gives some um, excitation to the plant that gives some output. So very easy to maintain. And also the system is generally stable because here the reference input is given to the plant through the controller and giving some output, and this output is not fed back and continuously changing. So the output is always same. So it produces the stable output, and it is very convenient to use where the output is difficult to measure. Then there is no need to maintain where the output is need not to be monitored continuously. Then open loop control system is preferred. Then what are the disadvantages of these systems? There are inaccurate output. As we told already, the output variable is not continuously monitoring. That means the output may be a desired one or not. We don't know. So the output may be inaccurate. In general, on any system, there may be a disturbance. Due to the external effects, there may be a disturbance. So, in general, the output may not be exactly accurate. It is in general, less accurate due to the feedback absence. And also, it is unreliable. That means the output is not same at all the conditions, and there is no control action and the output quantity. Always it doesn't give the same output for the same input under different conditions. So due to the external disturbance variations, the output will not be reliable. And any change in output cannot be corrected automatically. Since there is no feedback, there is no automatic correction of the output. Whatever the output delivered by the plant for the given input, that will be the final output. These are the disadvantages of open loop control system. To avoid or to overcome the problems in the or disadvantages in the open loop control system, let us know what is the closed loop control system which overcomes the disadvantages of the open loop system. And it doesn't mean that always the closed loop system is better than the open loop system. There are some disadvantages of the closed loop system compared to the open loop system. So these two systems are having their own advantages and disadvantages. But in general, in the application, we expect the more accurate output, um, even under the disturbances, we will we prefer the closed loop control system. And this is the model of the closed loop control system. In this system, we have generally the transducer at the input section, controller and plant, then output. This output is fed back through the feedback element, that is again a transducer. Therefore, the controller controls the plant parameters to get our desired output. Here, when the input is given, the transducer will convert the input from the physical form to the suitable form to the controller to take action on the plant. And the controller, depending on the error signal, the controller will generate a control signal to the plant, thereby the plant produces some output along the disturbance presence at the plant. This disturbed output is again fed back to the controller through the transducer again, because the output may be in different form with respect to the controller input or the reference input. Therefore, a transducer converts again this output into a suitable form to compare with the reference input. Therefore, the error signal will be generated to the controller. This controller takes the necessary action based on this error signal. That control signal control signal is given to the plant. Therefore, it will change its parameters and produce the desired output. This feedback action continuously monitors the output until we get the desired output. This is called the closed loop control system. This is the general block diagram of closed loop control system. Now let us see what are the control signals of each block. Here the reference input is given to the error detector denoted as R of t, and after the error detector, we will get the error signal E of t, which is given to the controller. Based on the error signal, the controller will generate a manipulated signal or controlling signal to the process. There, the process controls the parameters of the plant and delivers the controlled output C of t. And this C of t is again feedback through the feedback element. Say the feedback signal is B of t, and this is given to the error detector to get the error signal. Here, the feedback may be positive feedback or negative feedback. If it is negative feedback, the error signal E of t is equal to R of t minus B of t. And if the feedback is positive, then error signal is R of t plus B of t. Based on this error signal, the controller keeps on controlling the parameters of the process and delivers the output until it reaches our desired value. Here, the response characteristics of the closed loop control system are given. The output doesn't change and reach our desired value at very fast. Here, slowly, when the input is given, the output may not be our desired output. It will slowly increases or changes and reaches our desired value. When the output variable is varying, the response is said to be transient response, and after reaching a certain level of the desired point, the response is said to be steady state response. Here the response characteristics are shown in the blue color and our desired set point is shown in red color. To reach our desired level, the output variable is keep on changing and reaching almost near to a desired value, but there may be a error in acceptable range. In general, for the dynamic response of the second order system is given like this. It will the output variable is fluctuated till some point called the transient period. After that, it will reach and stays at some limits and close to the desired value. That period is called steady state period. Now we'll see some examples of closed loop control system. Now we'll see an example of closed loop control system, that is student and teacher learning process. In this process, the lecture content is given to the students before starting the lecture, and teacher teaches the lesson. The student listens the lesson and grasps the content. Finally, after completing its course, he will get a degree and placement. But the quality degree and getting the placement is depending on the performance of the student. So the performance of the student is periodically monitored by the teacher by conducting the quizzes. This in this process, the lecture content is the input and teacher is the controller who controls the teaching methodology to make sure that the student performance improves. And the student listening ability and grasping the content and make sure that his performance is better is the process, and degree or getting placement is the output, and teacher conducting the quizzes is the feedback based on the expectation level of the marks and the placement. In the second example, I will show two images. Please identify and compare these two images. In the left hand side we have the old iron box, and at the right hand side we have new iron box. Here in the old iron box, we have to manually adjust the coal to get our desired temperature, and also we have to manually check whether the clothes are dried or not. In the new iron box, we have to manually adjust the knob of the temperature to our desired point, but no need to check whether the clothes are dried or not. Automatically the sensor will sense the temperature and switches off whenever the temperature exceeds the limit. Now we'll see the next example of closed loop control system, that is stability control of quadcopter. First we see this video, then I will explain how it is controlled.
Drones have incredibly sensitive flight controllers that can help compensate for things it may encounter. Say a gust of wind blows too hard on the right side, it'll compensate and keep it steady. Say one of the propellers goes out, it can compensate and still keep it in the air.
You can also plan a flight path so that it's literally going to follow your instructions and use that GPS in order to be able to figure out where to go. You can have literally a drone follow you like a pet.
Yeah, from the video, we can understand that we have to stabilize the quadcopter altitude level. First, we'll set our desired altitude level to the quadcopter and we'll send the altitude level to the controller. Then the controller sets and make sure that the quadcopter achieves its desired altitude level. But when there is a disturbance like a strong wind, then the altitude level of quadcopter may change. That output is fed back to the controller, then controller controls the parameters of the quadcopter to achieve the desired altitude level and maintains its altitude level, that is nothing but stability control of quadcopter. The next example of closed loop control system is autonomous car. Autonomous car is nothing but driving a car without driver. To drive without a driver, we need to give all the information of the driving route to the autonomous car through the different sensors. So the autonomous car or the control system inside it will keep on monitor the position or the driving route continuously and controls its motor to get or to drive in a desired route. See this video can understand how the autonomous car works. Till now, we have seen some examples of closed loop control system. Now let us move on to the advantages and disadvantages of closed loop control system. In closed loop control system, even the presence of nonlinear components, the output is accurate. Because of feedback, we are trying to reduce the error signal, then the output will be more accurate at the presence of non-linearity components too. And second one is it facilitates the automation. Due to the feedback, it automatically corrects the signal to our desired level. The sensitivity of the system may be made small to make the system more stable. Since due to the feedback, the sensitivity of the system is improved, therefore it achieves more stable. This system is less affected by the noise. Because of the feedback, we always measures the output under disturbance and corrects the disturbance by taking continuously the feedback and will reduce the noise effect on the output. Therefore, the effect of the noise is less. Then we'll see the disadvantages of the closed loop control system. Due to the presence of the feedback and extra components used, it is very costlier and complicated to design. This complicated design is due to the feedback and continuously monitoring of the output to get our desired level, and require more maintenance. Due to continuous monitoring of the output variable, maintenance is required, more maintenance is required. Feedback leads to oscillatory response. Due to the feedback system, the output variable will not suddenly goes to the desired level. It will oscillate and slowly reaches to the steady state. Then overall gain is reduced due to the presence of feedback. Because of the feedback gain, the overall gain is reduced if the feedback is negative. The stability is a major problem and more care is needed to design a stable closed loop system. Since the external disturbance is present at the output is not stable, is less stable. So to improve the stability of the system, we have to carefully design the controller to provide more stable at the output. Now we'll compare the open loop and closed loop control systems. In the open loop control system, the feedback is not adjusted, and in closed loop system, feedback is adjusted. Therefore, the changes in the output reflects at the input in closed loop system. In open loop system, due to the absence of feedback, if there is any change in the output, that doesn't affect at the input. In open loop system, output measurement is not required for the operation of the system. Since there is no feedback, there is no need of output measurement. But whereas in the closed loop control system, output measurement is required to feed that output to the controller back to take the necessary action. In open loop system, feedback element is absent as already you know, and in the closed loop system, feedback element is present. In the open loop system, error detector is absent because there is no feedback, there is no error detector presence required. And in the closed loop system, error detector is necessary because the feedback signal is compared with the reference signal to generate the error signal. And in open loop system, it is inaccurate and unreliable. The open loop system is inaccurate means when there is an external disturbance at the output that doesn't that will not be corrected by the system. So the output is inaccurate when there is a disturbance. And also it is unreliable when there is a disturbance and it is random. Even the input is same, the output will not be same at the same input conditions. Whereas in the closed loop control system, it is highly accurate and reliable. Due to the presence of feedback, it keeps on monitor the output and corrects the output variable to its desired value. And also, it is reliable even though there is a disturbance, the disturbance will be corrected and will give the same output at the same input condition, even the disturbance is random. In open loop control system, it is highly sensitive to the disturbances. Since there is no feedback, there is no correction for the disturbances, it is highly sensitive to the disturbances. But in closed loop control system, due to the feedback, it corrects the effect of the disturbance on the output variable, so it is less sensitive to the disturbances. In open loop system, it is highly sensitive to the environmental changes. These environmental changes are unavoidable, so it is sensitive and there is no correction and in the open loop control system. Whereas in the closed loop control system, due to the feedback, it also corrects the environmental changes by continuously monitoring the output variable. In this open loop control system, once if we give the input, it will deliver the same output always, and there is no changes in the output variable. The bandwidth is very small. Whereas in the closed loop control system, due to the dynamic action of the system, the bandwidth is very large. In the open loop system, it is very simple to construct the system and it is very cheap. In the closed loop control system, the design is very complicated, hence the cost is also high. In open loop control system, generally the output is stable because there is no correction. By taking the feedback, it always produces a stable output. In closed loop control system, stability is a major consideration while designing the system because there is a feedback, it always controls the output variable. Therefore, there is a care needed in the designing of the control system to achieve the good stability. In the open loop control system, highly affected by the nonlinearities. Due to the nonlinear components used in the open loop system, the nonlinear effects are affecting the output. Whereas in the closed loop system, even though there are the nonlinear components used in the system, due to the presence of feedback, the nonlinear effects are reduced. These are the differences of open loop and closed loop control systems. Before going to end the session, let me recall what we have learned in this video. We have learned the classification of control systems, that is open loop and closed loop systems, with examples for both open loop systems and closed loop systems. And also we have learned the advantages and disadvantages of open loop and closed loop systems. And finally, we have compared these two systems to know the differences. In the next video, we will learn about the block diagram representation of a given control system and the block diagram reduction using block diagram algebra. Thank you.